Let us review the important properties and formulae in hyperbola. So the definition of the hyperbola can be taken as this one. It is the set of all points in a plane, the difference of whose distances from two fixed points in the plane is a constant. The fixed points are called the foci. So the diagram of the hyperbola looks like this, and we can see that it has two branches. The points F1 and F2 are the two foci of the hyperbola, and the two dotted vertical lines represent the directrices. The line segment LL dash is a latus rectum. So the equation of the hyperbola is in this form: x squared by a squared minus y squared by b squared equals 1. And we can see that this is very similar to the equation of the ellipse. The only difference is that we have minus b squared in the place of b squared. The eccentricity is given by e squared is equal to 1 plus b squared over a squared. Now e for a hyperbola is always greater than 1. The foci is given by the point plus minus ae comma 0. The directrix is the line x equals a by e, and also the line x equals minus a by e. The vertices are the points plus minus a comma 0. Now there are other formulae. So the transverse axis is given by the length 2a, the conjugate axis is the length 2b, and the distance between the foci is 2ae. The distance between the two directrices is 2a by e, and the latus rectum is 2b squared by a. So we can see that a lot of formulae are very similar to what we have seen in the ellipse. A rectangular hyperbola is one for which a is equal to b. So its equation can be taken in this form, and the eccentricity of a rectangular hyperbola is the square root of 2. Let us look at the concept of the conjugate hyperbola. So if x squared by a squared minus y squared by b squared equals 1 is a given hyperbola, then its conjugate is y squared by b squared minus x squared by a squared equals 1. And the conjugate hyperbola is drawn like this. It's vertically aligned, and the foci also lie along the y-axis. If E1 is the eccentricity of the original hyperbola and E2 is the eccentricity of its conjugate, then we have this relation: 1 divided by E1 squared plus 1 divided by E2 squared is equal to 1. Let us review the concept of tangent and normal. So the equation of the tangent at the point x1 comma y1 is given by this formula. So we have replaced x squared with xx1 and y squared with yy1. The condition for tangency of the line y equals mx plus c is this one. So c squared is equal to a squared m squared minus b squared. The normal at the point x1 comma y1 is given by this formula, and it can also be written in this form. There are some additional formulae. So the equation of the diagonal circle is x squared plus y squared equals a squared minus b squared. The parametric equations are x equals a secant theta, y equals b tan theta, and the asymptotes are two lines given by x by a minus y by b equals 1 and x by a plus y by b equals 1. So these are two lines which are tangent to the hyperbola at infinity.